to today's lecture. So this is lecture 1, ICT, and we're going to discuss computers, and under this we're just going to look at the introduction to computers, and then in the next lesson that we're going to have, that's when we look at the anatomy of the computer, meaning the inside part of the computer. And apart from that, we also do a sample question on how to convert binary numbers, which are base 2 numbers, to decimal numbers, which are in base 10. So let's look at what a computer is. So first of all, we're going to start by defining what a computer is. So a computer is simply just an electronic device that can perform activities that involve mathematical, logical, and graphical manipulations. So this is just one way in which we can define a computer. When you go somewhere else, you find people defining a computer according to how they use it, or according to how they operate it, or according to the works that it does for them. So a computer can also be defined as an electronic device which accepts data input from the external environment, processes it, and stores it or retrieves it, meaning it produces it in a form of useful output information. So the second point here is actually the main definition of a computer. At least this one describes what a computer is in a general way. This one was too specific. It was just pointing out mathematical, logical, and graphical manipulations, but a computer can do way much more things than just mathematical, logical, and graphical manipulations. So it can do a lot of things. So this is the general definition for a computer. It is just any electronic device. It is just any electronic device which can accept data input, meaning you have you need to have something that you need to use to insert data, to put data into a computer. Then after putting that data into a computer, the computer will process that data to the form that is useful to a human being, or rather to a system in which the computer is working, or an environment in which the computer is working. So these appliances or gadgets or electronic devices that are used to input data into a computer are simply known as input devices. So they are known as input devices. We are going to discuss them in details in the next lecture. And then we also have this part of the processing, process. So this processing part is done by the processor, or rather by the CPU. Sorry, not the processor, but the CPU, which is the central processing unit. So the CPU also consists of 3 parts. It consists of the memory part. So we're going to discuss everything in the next slide. We also have the ALU. We'll discuss this as well, and which is arithmetic and logic. So we're going to discuss this. We're going to discuss it in the next slide. Okay. So I said it contains the processing part consists of 3 parts as well: the memory unit, and then the ALU, which is the arithmetic and logic unit, and then it also consists of the storage part. But the main ones are the memory unit, the arithmetic and logic unit, and also the control unit. So the control unit. So these I was just abbreviating, otherwise you're supposed to write them in full. The memory unit. And then this one is the arithmetic and logic unit. So this is contained in the processing unit, the central processing unit. Okay, so and then apart from that, you also need to have the output devices. So these are the ones that decodes the information from the computer and presents it as useful information to the environment. Okay, so let's look at the computer. So the computer is applied in most of our day-to-day functions in achieving the intended goals and objectives. Its use ranges from education, research, planning, controlling, and programming of automated systems. So we're going to look at these one by one in the next slide as well. As I said when introducing this slide, I said we're just going to look at the introduction of everything that we're going to look at. So we've not yet started learning. This is just an introduction. So from there we can also look at examples of automated systems. These automated systems are, we have the banking and the security system. Yeah, this is where you find a computer that has been programmed. It just works automatically. Yeah, even in the manufacturing industry you find such computers. Yeah, so a computer is useful as electronic storage files. Yeah, so these are some of the uses of a computer, which we're going to discuss one by one in the next slide. So it's used to store very large and small files. Okay, so the computer uses the input device. So the input device, I said these are just gadgets that are used to like inject or input information into the computer, or to feed the computer with certain information in form of codes. Yeah, so the examples of these are keyboards. We have a keyboard, a touch screen. Yeah, and then apart from that you also have scanning devices. Yeah, so these are just used to capture data and then insert into the computer. So it uses the processing devices as well. So under the processing devices we have the processor there, then we have the main memory to process the data. Yeah, apart from that we also have the control unit in the central processing unit. Okay, so we have apart from the control unit we also have the arithmetic and logic unit. It is also important to discuss that. We're going to look at it in details. So this data and information can be communicated to a remote terminal or be stored in a computer for future use. Yeah, so we'll discuss about the storage part of the computer. So the same data and information which is meant for human use can be converted into human sensible form by using the output devices like the printer. We have the screen of the computer, and then we also have the output microfilm. So the output microfilm, I'm sure you people have seen something like this, those films that are used sometimes in cameras. Yeah, so I'm sure you've seen something like this before. Okay, so generally the term is used to describe a collection of devices that function together as a system. Yeah, so the computer can be, the computer is just a term that is used to describe a collection of devices that work together as a system. So what they mean here is that a computer is not just the laptop that you know, it's not just the desktop that you know. The computer can also mean a calculator. It can also be anything. It can even be a phone. Anything that is made of a collection of devices, different devices connected together to form something that is called a system. Okay. So a computer performs the three operations that I just mentioned, which is the inputting, processing, and outputting. It performs these operations in a sequence. So in this sequence, the first thing is that it receives data and instructions from the input devices, and then the second thing is that it processes the data as per instruction, meaning according to the way you've instructed the computer, it's going to give you it's going to process that data that you've given it according to the instruction that you've given it. if you've told it to say you should add 2 and 3 after subtracting 5, it is just going to do exactly like that without even missing anything. That's what even makes computers to be more accurate, and at least they are diligent. In short, we'll learn about the characteristics of computers. They are diligent, they are accurate, they are very speed. I mean, they have a very high speed, like than normal human beings. Yeah. So we'll learn about the characteristics of a computer very soon. And then it provides the result, which is the output in a desired form. So after processing the data as instructed by the by the person using that computer, it will provide the result. It will provide the result as so it's going to provide the result as the output in the desired form. Okay. So it consists of the input devices through which the data is accepted, and then it also consists of the processing unit which processes the data, and then apart from that the computer also has output devices which decodes the information. And then it also has storage hardware. So this storage hardware is the one that is mostly used for storage of information. Yeah. Okay. So computers are also made in generations. They are also made in generations. So the first computer was invented in somewhere around 1936. 1936, and then they started adding these other components in 1946 going up. So from 1946 to 1954, they introduced a vacuum tube, and then a vacuum tube computer, and then from there they advanced a bit. They introduced transistors. From there they advanced into integrated circuits, which are the ICs. Yeah, I'm sure you've heard about IC. So these are integrated circuits. Then apart from that, they went on and advanced to very large scale integrated circuits, which are VSLI. And then apart from apart from that, we have the fifth generation, which is the ultra scale integrated circuits, which is ULSI. Which is these are microprocessors which are made of silicon chips. Okay, so we have a lot of computers right now. We even have eighth generation. Okay, so let's look at this sample question here. I promise that at the end of every computer lesson, we're going to be having a practical question. From the practical question, that's where I'll be getting the exercise. So after solving this question, I'm going to give you an exercise on this sermon. So the question says convert 1001110 to base 10. So what you do when you're converting that to base 10, what you just need to do is you write your number. You have 1, you have 0, 0, 1, 1, 1, 0. Then write just down here. You put you write 2's there under the each number on top there. From there you put numbers starting from 0 going up. You have 0, 1, 2, 3, 4, 5, 6. So we're going to say 2 to the power 0, the answer is 1. 2 to the power 1, the answer is 2. 2 to the power 2, the answer is 4. 2 to the power 3, the answer is 8. 2 to the power 4, the answer is 16. 2 to the power 5, the answer is 32. 2 to the power 6, the answer is 64. So from there we're going to multiply these numbers on top here with those numbers down there. So I have 1 times 0 there. 1 times 0, the answer is 0. We say plus 2 times 1, have 2. 4 times 1 plus 4. We have 8 times 1, we have 8 there. And then we have plus 16 times 0, 0, 32 times 0, 0. Then we have 64 times 1, we have 64 there. So now we add these numbers to get the answer. So we have 64 plus 8, the answer, okay, let's start from this side. 0 plus 2, the answer is 2, plus 4, the answer is 6, plus 8, the answer is 16. So 16 plus 64. So we add 64 plus 16. So we have 0 there, then we have 7, we have 80. So this is supposed to be 14. When you add 6 plus 8, the answer should be 14. Then 14 plus 64, this will give us 78 and not and not 80. So we have 78 there. So now if you want to convert this 78 back to this number, it's also simple. Okay, let me give you another example of how to convert base 2 numbers to base 10, and then we'll do another conversion which is from base 10 to base 2. So we have, let's say for instance you have 1 0 1 0. You want to convert this to base, this one is in base 2. You want to convert this into base 10. So base 10 means that you're going to write 2 2 2 2 there. So you have 0 1 2 3. So 2 to the power 0 1, 2 to the power 1 2, 2 to the power 2 4, 2 to the power 3 8. So from there we can start multiplying. 8 times 1, the answer is 8, plus 4 times 0, the answer is 0, 2 times 1, the answer is 2, 1 times 0, the answer is 0. So when you add these, 8 plus 2, the answer is just 10. So in short, 1 0 1 0 base 2 is equal to 10 in base 10. This is what it means. Alright, so from there, let us now convert this 10 back to base 2. So let me also submit to you that numbers in base 2 are called binary numbers. Binary numbers. Why are they called binary numbers? Because of this bi in front there. Bi means 2. So bi means 2. So we also have decimal numbers. Decimal numbers, deci means 10. So decimal numbers are just numbers in base 10. We also have hexadecimal numbers. So hexadecimal numbers, it means that we are combining hexa and decimal, meaning this one is base 10. Decimal number is base 10, and then hexa means 6 from the word hexagon. So a hexagon is simply just a polygon with 6 sides. 1 2 3 4 5 6. So hexa means 6. So this one is base 6. So base 6 plus base 10, meaning you are going to have base 16 when you combine hexa and decimal. You are going to have base 16. So hexadecimal meaning we're talking about base 16 numbers. Alright, let's proceed to converting back. So we had 10. We are going to convert this 10 in base 10. We're converting it to base 2, which is binary. Okay. So what you do is that you just use successive division. So we're going to put 10 there. Then we're going to write 2. 2 into 10, the answer is 5, remainder 0. 2 into 5, the answer is 2, remainder 1. And then 2 into 2, the answer is 1, remainder 0. 2 into 1, the answer is 0, remainder 1. So we have the remainders this side. So just copy the remainders starting from down going up. So we have 1 down there, followed by 0, followed by 1, then followed by 0. So this is our number is in base 2. Yeah, so I've converted 10 to base 2. So you can do the same for 78. Alright, so you can do the same for 78. So we're going to use successive division. Let's hope we're going to manage to write them here. So I'm going to write small numbers. we have 78 there. We're going to be writing the remainders there. Okay, so 2 into 78, 2 into 78 have 39, so we have 39, remainder 0. Then 2 into 39, we are going to have 19, remainder 1. And then 2 into 19, we have 9, remainder 1. Then we have 2 into 9, the answer is 4, remainder 1. We have 2 into 4, the answer is 2, remainder 0. 2 into 2, the answer is 1, remainder 0. 2 into 1, the answer is 0, remainder 1. So we copy these numbers starting from down going up. So we have the first number there is 1, second number is 0, third number is 0, fourth number is 1, fifth 1, sixth 1, and then the last number there is 0. So this is the number in base 2 is equal to 78, which is in base 10. So this is simply how you convert numbers. Yeah, so it's not something that is difficult, something that is very much straightforward. Yeah, so this is basically how you convert numbers from one base to another base. So next time we're going to meet, we're going to convert numbers from base 10 to hexadecimal and from hexadecimal to base 10. That's what we're going to do. Then after doing that, we'll also start looking at other practicals like PowerPoint and other Microsoft applications. So next time we meet to look at anatomy of the computer. We'll discuss the computer anatomy in details. In short, we are going to discuss the computer in details. Thank you very much for watching tonight's lecture. See you in the next lecture. Don't miss. My name is Harmtedy. Shalom, shalom.